So crude oil is a mixture of hydrocarbons, and a mixture is just a group of molecules or elements or compounds that aren't actually bonded together. So the individual compounds will have atoms bonded together, but the compounds won't be bonded to one another. Okay, so a mixture is then able to be separated into its different compounds, molecules, or elements, depending on what forms the mixture. So for crude oil, it's usually compounds, and those compounds are hydrocarbons. They're compounds because they consist of two different types of element joined together. So a mixture is easy to separate because they're not bonded. The individual compounds are not bonded to one another. So you'd have different hydrocarbons kind of in the mixture together. Like, for example, this one with hydrocarbon would have hydrogens all around it if it's an alkane. And you could have another one separate next to it that might have, let's say, 5 carbons instead of 3. And then these lines are just all pointing to hydrogens, you have to imagine, or it'll take forever. Okay, so this one's a longer hydrocarbon chain. So longer hydrocarbon chains need more energy to be formed into gases. And that's just because there are more atoms in a longer one. This means that basically that's one thing you can do to separate the two compounds. So because this one will take less energy to turn into a gas, you can use the heat to make this one into a gas, and this one will remain a liquid still. So this one will rise all the way to the top of a container, while this one will stay at the bottom as a liquid. Okay, so that's why it's easy to separate. Okay, and that's why we use fractional distillation. Fractional distillation actually is just about heating crude oil in a fractionating column. So fractionating column. Okay, and it basically gets rid of the mixture. It separates it out into fractions. Fractions are just made up of one hydrocarbon length of chain, really. So if you imagine this is the column, there'll be heat down the bottom, and there'll be pipes coming out at different levels. So you start off with crude here at the bottom, and you vaporize it. Vaporizing just means you just make it into a gas. So we all know that to make something into a gas, you need to make it kind of vaporize. But to make it into a liquid again, you need it to condense. And the boiling point is the point at which condensation will happen below this point, and vaporization will happen above it. So above you get vapor, below you get liquid. And this means that basically the long carbon chains are the ones that first come out, because they're the ones that have a higher boiling point. So even close to the heat source, where it can be up to 340, 500 degrees, you have the big chains, which actually won't even stay gas at 340 degrees. And we call that the oil part of the fraction. So that's the oil fraction, the first one. The one with a boiling point at around 340 or just above 340, which means it turns into a liquid at that point. So oil will be fractionated out at 340 degrees. And oil has a 35 carbon hydrocarbon chain, so it has 35 carbons in it. And that's why it takes so much energy, because there are 35 carbons to fix up with it. And then we have diesel. Whoops. Diesel is about a 20 carbon chain. It fractionates out at 250 degrees. Then we have kerosene. Now we all know what kerosene and diesel are used for. Well, mainly we know what diesel is used for. It's for cars, obviously, and machinery. Kerosene is used for planes. It's just a slightly lighter fluid kind of that can be used for jet fuel. Okay, and kerosene obviously has less carbons than diesel, and that's why it boils at a lower point and also condenses at a lower temperature. So it has 15. So can you see there's kind of a bit of a pattern here where it goes from diesel having 20 to kerosene having 15, and then naphtha is the next one and it has 10. So we're actually doing the 5 times table backwards at the moment, and that comes out at 110 degrees, and that's naphtha. Okay, then we have petrol. Petrol is tiny. It's the actually this is where the pattern breaks. It's not the 5 times table anymore. It's a 8 carbon chain, and it comes out at 40 degrees because it's so small. And obviously that's used for cars. Naphtha is used in kind of different things. It's not so clear, naphtha, and you won't really need to know that. But petrol is used in cars, obviously diesel is used in cars, kerosene is used in planes. Okay, and then what we have at the end is refinery gas. Refinery gas is what you have in camping gas, okay, when you take a camping canister of gas. So there you go. And that's all you really need to know for the beginning parts of fractionation or fractional distillation.